Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. We're going to continue today talking about graphing quadratic functions. Yesterday we learned how to graph a quadratic function by using properties. We learned how to find the axis of symmetry, which is, remember, that invisible line that cuts the graph in perfect halves, the parabola, that U-shaped graph. We learned about the vertex. You plug in the value of the axis of symmetry into the function and you find the y. So that x value and that y becomes the vertex. Remember, the vertex is either a maximum or a minimum. It's a maximum if the graph is pointing downwards. It's a minimum if the graph is pointing upwards. Then from there, we could find the y-intercept. We find the mirror image. We connect the dots, and we have our parabola. We know that if we wanted to solve the parabola by graphing, we would have to find the x values either by recognizing that they were perfect points on the graph or by factoring using the square root method, the quadratic formula, or completing the square. So that's where we are. Now today I'm going to take you to a more advanced level of the quadratic functions and graphing them. It's going to be a lot easier today. And you're going to be able to learn how to manipulate the standard form of y equals ax squared plus bx plus c, okay, into the form called vertex form, which we're going to learn today. So it's pretty awesome. Let's first understand, guys, that every parabola, every quadratic function is a simple manipulation of the parent function y equals ax. A being the coefficient, of course, of x squared. So I'm sorry, I just made a mistake on this video. Parent quadratic function is ax squared. Sorry. If I go ahead and graph this parent function, we could use a very simple table, -1, 0, 1. We're going to get 1, 0, 1. So 0, 0, 1, 1, -1, 1. This is my parent quadratic function. Remember that we've already dabbled in transformations with that h and that k. You remember that, guys? The good news. Today I'm going to review all of that, but you kind of already know what's coming. So what's going to happen here is, from now on, any quadratic function we graph, it's simply a transformation, okay, a manipulation of this parent graph right here. How so, Mr. Morrow? Let me show you. We're going to learn today the vertex form of the quadratic function, which is, just like I said, the manipulation of a parent quadratic function, y equals ax squared. The vertex form is y equals a x minus h squared plus k. Let's investigate every single part of this. The a is very important when analyzing a quadratic function. We already know that if a is positive, we know that the parabola will point upwards. We did this yesterday, so I'm not going to go spend too much time. We know if a is negative, it's going to point downwards. Again, I know I'm going real fast, but we know this already. I don't want to bore you. Here's the fun part. The A has something else that's very powerful. Please pay attention. Remember, if it's positive or negative, that tells you if it goes up or down. But if the absolute value of A is greater than 1, then the graph stretches vertically and becomes narrower, which is a vertical stretch or a horizontal compression. Let me explain. If I graph y equals x squared, I have 0, 1, 1, and 1, -1. That's my graph. Let's go ahead now and increase that a. Let's make that a value greater than 2. Let's see what happens. Go ahead and graph this function, ax squared. -1, 0, 1. -1 squared is 1, so that's a 2, 0, 2. So I've got 0, 0. I'm going to do it in green. 1, 2, and negative 1, 2. Guys, what happened to this graph? It got narrower, right? Didn't it get compressed horizontally? Didn't it get squeezed horizontally? And didn't it also get stretched up vertically? Think of a rubber band. I know you're not going to be able to see this on the video, but just remember what I'm doing, okay? Here's a rubber band in normal state, correct? If I do a vertical stretch, doesn't it get thinner and thinner? And isn't it getting squeezed from the sides horizontally? Okay, that's what's happening here. So as your A, as the absolute value of A gets larger and larger, your graph gets narrower and narrower. You with me so far? Okay. Now, if A is greater than 0 but less than or equal to 1, and A cannot be equal to 0, sorry, that's a mistake. If A is greater than 0 but less than 1, sorry, that's a mistake. Get rid of that equal sign. If it's between 0 and 1, in other words, if it's a fraction or a decimal, then the graph gets compressed vertically. This is a vertical compression or a horizontal stretch. So this means it's going to get fatter. Okay? A vertical stretch, it gets thinner. A vertical compression, I'm squeezing down on it, so it's going to get fatter. Again, let me prove it. Y equals x squared, 0, 0, 1, 1, negative 1, 1. That's my parent function. Y equals 1/2 x squared. Let's make a table, negative 1, 0, and 1. Negative 1 squared is 1, so that's going to be a half, 0, and a half. I'll do this in red, 0, 0, 1 and 1/2 is here, negative 1 and 1/2 is here. So look at what happens. See how it gets wider, guys? Because it got squeezed down, correct? And horizontally, it got stretched. So a vertical stretch is the same as a horizontal compression. And a vertical compression is the same as a vertical stretch. So what does this mean again? If A is greater than 1, you know your graph is going to get thinner and thinner and thinner. If your A is between 0 and 1, it's a fraction or decimal, your graph is going to get wider and wider and wider. Sir? Horizontally, horizontal compression is a vertical stretch, so it gets thinner. No, that would be a straight line then. He asked if it's ever going to compress all the way to just being on the axis. No, it won't happen. That would be a linear function then. Okay, so does that make sense, boys? Let's continue. Okay, now let's talk about the H. We already know what the H does, guys. The H is a horizontal shift, okay? Remember, H is positive, but this little guy makes whatever value of H its opposite. If the graph shifts to the left, that many spaces. If it's positive, it's going to shift to the left. If it's negative, it's going to shift to the right. Remember that H shifts horizontally. So I have my y equals x squared. It's right here. Now I have x plus 3. Shift all of these points 3 to the left. 1, 2, 3. 1, 2, 3. 1, 2, 3. And that's it. That's my H, okay? If H is negative, okay? It's always the opposite of what's here. Okay, so I have H plus 3, it's going to go to the left. It's always opposite. It's always opposite. When H is negative, since I have a negative to begin with, okay? This is negative here now. I'm going to go to the right. So again, I have 0, 0, 1, 1, negative 1, 1. But this time I have x minus 3. It's always opposite So I go to the right now. 1, 2, 3, 1, 2, 3, 1, 2, 3, and that's my new graph shifted 3 to the right. You with me here, guys? So I have x plus 4 squared, 4 to the left. X minus 4 squared, 4 to the right. It's opposite. Why is it opposite? Again, because of this negative. The h value itself is independent. Again, if h is 4, aren't you going to have x minus 4? But that's why we go to the right, because the h is really 4. If I have h equals negative 4, wouldn't I have x plus 4? That's why I go to the left, though, because the original h is negative. So you always go the opposite of what is shown here. You feel me? Okay, next. The k. Okay, the k either shifts the graph up or down. If the k is positive, the graph is shifted up that many spaces. 0, 0, 1, 1, negative 1, 1. That is my parent function. I want to shift it up 2. Every single point goes up 2. 1, 2, up 1, 2, up 1, 2. That's my graph. Shifted. Does that make sense? If k is negative, this is not opposite. It just goes down that many spaces. So y equals x squared, 0, 0, 1, 1, negative 1, 1. That's my graph. But I'm shifting down 2. Notice it's away from the x squared. It's not in parentheses. So I'm going to go down 1, 2, down 1, 2, down 1, 2, and that's my new graph. Is this making sense? All of this should be kind of a reminder, right, of what we did before, right? Pretty simple. Okay, let's make it complicated now. And no, I'm kidding. I'm going to make this so easy for you, you're not even going to believe it. Okay. You guys know that this represents my h and this represents my k, right? Okay. This hk, let me see if you've realized this yet. This hk is the vertex. The vertex of any parabola can be written with the values of hk. That becomes the vertex. So when I see this here, I want to first find my h, which remember is the opposite of this. So what's my real h? Negative 2. My k is 1, right? So my vertex right off the bat is negative 2, 1. Look how easy this is now. Find and graph the vertex, which I already showed you how and why to find it. Step 2, find and graph the y-intercept, which is the y value when x is 0. When I make this x 0, guys, isn't this 0 plus 2 squared plus 1? Hello? Yeah? What's 2 squared? Plus 1? That's my y-intercept. And then step 3, this only happens if the vertex and the y-intercept are the same ordered pair. If the vertex and the y-intercept are the same ordered pair, plug in any value for x and find its corresponding y value, then graph the mirror image. Okay? Or you can solve like we know how to solve for the x-intercept by factoring, completing the square, using the quadratic formula or the square root method. But this only has to happen if the vertex and the y-intercept are the same. Or if I tell you solve by graphing. But 90% of the time, they're not going to ask you to solve by graphing, even on the SAT. They're going to say graph this. Find the domain, find the range, find the vertex. They'll say find the axis of symmetry. But not too often are they going to say to solve it. But if they say solve, my boys have the tools. And maybe my girls out there in the internet world. They have the tools now. Okay? Does that make sense, boys? So let's do this. My vertex was negative 2, 1. So negative 2, 1. My y-intercept was 0, 5. 0, 5. 1, 2, 1, 2, 3, 4, 5. Now, you may be thinking, what happened to the axis of symmetry? Guys, isn't the axis of symmetry going through the vertex? Because isn't the axis of symmetry the x value of the vertex? Are you making connections here, guys? You promise? Because if you are, this is going to be super simple. Now, mirror image. 2 to the right, 2 to the left. You're done, guys. You're done. And what happened here? The parent graph was shifted 2 to the left and up 1. And when you look at this, that makes sense, doesn't it? It was shifted 2 to the left and up 1. Does that make sense, guys? Yes, sir, my brother. You could have used the parent function, but that would have been a waste of time. Then what you would have had to do is you would have had to graph y equals x squared. Then shifted it to the left and up 1. You mean to tell me that that's harder than saying negative 2, 1. Here's my axis. Here's my y-intercept, mirror image. I'm done. If you want to do it the long way, God bless you. I don't judge you at all. It's up to you. Thank you, sir, for caring. May I continue, boys? Okay. Now, here comes the fun part. You guys remember how to complete the square? Okay. This is going to be very similar to completing the square, but I'm going to show you a shortcut. Okay? Bear with me. It's going to be fine. I want to write y equals x squared plus 8x minus 5 in vertex form. And then from there, I can graph it. Okay, what do? I'm changing from here to here. Okay? Step 1. Separate the c from x squared plus 8x minus 5. And go ahead and drop this y and make it a 0. So what you're going to have now is x squared. I'm sorry. I'm completing the square. I'm dummy. Just separate it. So I have x squared plus 8x. Give yourself a little space and put the negative 5 over there. I put it pretty, whoa, wrong way. Wrong way. Sorry. That's it. Okay. Okay? And if you want, you can go ahead and encapsulate the x squared and the x together. You're separating the negative 5 from that term. Okay? Now, step 2, which I already revealed, sorry. Complete the square. Complete the square. That's my b, right? Complete the square, but this time, you know how you would add to the other side the b over 2 squared? Since we're creating an equation and I'm not solving, don't add it to the other side, because if you add it to the other side, you're going to have to subtract it back to the original side. So instead of going back and forth, complete the square and subtract the b over 2 squared from the c value instead of sending it to the other side. So what the hell am I saying? I'm saying this. X squared plus 8x plus my b over 2 squared, in this case, is 4 squared, right? I have minus 5 minus the 4 squared. Are you guys with me here? Are you guys with me here? Okay. Much prettier looking, it would be right up. Much prettier, it would be right here. Okay? I completed the square. I took my b over 2 in this case is 4 squared. I took that 4 squared and I subtracted it from the c that I just isolated. Are you with me here, guys? Promise. Correct, thank you. Normally, instead of doing that, we would have added it over here, right, guys? But then if I add it over here, don't I have to subtract it over here anyways at the end? I'm going to have to do that. So instead of doing that and complicating your life, simply complete the square and subtract the b over 2 squared from the c value you separated in step 1. Are you with me? Now, here comes the easy part. Okay? Go ahead and factor the perfect squared trinomial, simplify, and write in vertex form. What does this guy factor out to be, my brothers? X plus 4 squared, right? And then what's negative 5 minus 16? No. Guys, negative 5 minus 16. Negative 21. And guess what? You're done. Now, what's my vertex? Guys, what's my vertex? Remember, my vertex is my HK, right? So my vertex is negative 4, negative 21. What's my y-intercept? When x is 0, what's 4 squared? 16 minus 21? And that's it. Now we can graph this. Just real quick, let me just do a little sketch here to show you. So negative 4, negative 21, let's just say, just for giggles, let's just say that's negative 21. So negative 4, negative 21 is here. 0, negative 5, let's just say that 0, negative 5 is here. My axis of symmetry, okay? I went 4 to the right, go 4 to the left, and that would be my graph. Like, perfect and accurate and beautiful. Does that make sense, boys? Okay, now, one last thing that I got to teach you. What happens when instead of having a 1 in front of the x squared, you have an a that is greater than 1? You have an a here. Almost identical steps, okay? So don't stress. 1, separate the c from y equals ax squared plus bx, but also factor out the a from the ax squared plus bx. So what am I saying? I want to take negative 3x squared plus 6x, and of course I separate the c. You with me, guys? But then I can factor out a negative 3 from here, right? So factor out a negative 3, and then I have x squared plus 2x minus 1. So all I did was separate the c. Huh? What did I do? Wait, what did I do? What did I do? Oh, sorry. It's minus 2x. Sorry, my bad. Okay. Now, this negative 3 here, I got to do something with that as well. I've got to add that, subtract that to the c that I just took out. So I have the factored out a, which I have to subtract from the c that I separated. Now after this, it's all the same. Complete the square and multiply the b over 2 squared to the a that you factored out. So what am I talking about? I've got right now negative 3 times x minus 2x. My b is negative 2. b over 2 is negative 1, which I'm going to square. I have my minus 1, which was the c that I pulled out. I have minus my negative 3, which is the a I factored out, times the b over 2 squared. Does that make sense what I just did here, guys? Please pay attention because I got 6 minutes left. So I need to do a good job here. Does this make sense? Again, this is the negative 3 I factored out. Okay? This is the c that I pulled away. I have to subtract the a that I factored out. This is my b over 2 squared, which I must multiply to the a that I factored out. You guys with me here? Okay. Step 3, factor the perfect square and simplify. So I'm going to have negative 3 times x minus 1 squared. And I've got negative 1. Okay, I've got a 1 here. 1 times negative 3 is negative 3. Negative 3 times a negative is positive, so this is going to be plus 2. And ding dong, the witch is gone. Does that make sense, guys? Now, you sure? Because this is it. This is all we have to learn today. I think I have one example here. No, I don't. Does this make sense to everybody, what we just did? You promised me. Yes? Real quick, just to run through it, okay? I don't know how ugly this is going to be or not. But let's just say I have 2x squared plus 3x, I don't know, minus 5. I'm just pulling this out crazy. All right, let's do this. First thing and actually, let's do this the right way. Let's make that a 4x to make our lives a little easier. First things first, factor out the 2 from here. Separate the c and subtract the a that I just factored out. You with me? Now complete the square. X squared plus 2x plus b over 2, which is 1 squared, minus the c, minus the a that you factored out, times the b over 2 squared. Does it make sense? Now it's Mickey Mouse. 2x plus 1 squared. That's negative 2, so minus 7. Real quick, what's my vertex, my HK? Negative 1, negative 7. What's my y-intercept? When x is 0, we got 1 squared, which is 1 times 2 minus 7, negative 5. And then if I wanted to graph this, I very well could very easily graph this, which I'm going to do which I'm going to do right now. Oh, okay. Got my eraser a little bit messed up here. Sorry. So I've got my vertex, which is negative 1, negative 7, negative 1, 1, 2, 3, 4, 5, 6, 7. I got my axis of symmetry, which is going down negative 1. And I've got my vertex of negative 5, 1, 2, 3, 4, 5. That's 1 to the right, go 1 to the left. Ping, pong, boom. That's my graph. Sir, I don't have to do anything with the 2. That's the beauty. Isn't this thinner already than the normal graph? Why is it thinner? Because my a is larger than 1. That's the beauty of this. You don't have to worry about the a. As long as you write the function correctly, I promise you, all of your points will adjust to that. Thank you very much. I hope you guys learned a lot. Have a wonderful day. Homework is valid. We'll quiz on Monday.